magnetic field and the electric field. And together they give us what's called the Poynting flux, which is the energy flux of the corona. And to make those measurements, we have to actually go into that plasma and put sensors in the plasma to measure magnetic fields and electric fields directly, and that's what fields will do. Solar wind is the escaping atmosphere of the sun. It's the escaping corona of the sun. The corona is heated in a way that we don't understand yet, presumably involving magnetic fields, by energy that comes from below in the photosphere. And it's heated to such a high temperature that it can escape the gravitational potential of the sun and become an escaping wind, a stellar wind, a solar wind. Well, the design of the Fields instrument is a new thing for solar wind physics. It kind of combines two previous styles of experimentation. There are two ways to measure electric fields in space. One is using a technique that's called a double probe, and there's another technique which is measuring plasma waves or radio waves, and Fields for the first time brings these two techniques together. I think the very first data that we get will be revolutionary. At first blush, it'll just be a bunch of numbers as a function of time, but the science team, will take those numbers and make visualizations in the form of spectrograms, and eventually those data will be related to models, and so we'll be able to compare directly 3D visual models of the coronal magnetic field. These measurements have never been made in the environment close to the sun. We've made measurements similar to this in the Earth's magnetosphere, Earth's ionosphere, but putting a package like this into the solar corona it's just never been done. The closest anyone's ever been to the sun, and based on what we've seen so far from spacecraft not quite as close,